During the dry season on the African savanna, the environment itself becomes a lethal obstacle. Daytime temperatures climb past 104 degrees Fahrenheit before plunging to 59 degrees at night, subjecting every living thing to immense thermal stress. As the grasslands dry out, reliable rivers shrink to isolated pools. In this harsh window, a quarter of the animal population will perish simply from a lack of food and water. Withstanding extreme heat and dehydration is merely the baseline for existence here. Those that endure the climate must then face hunters waiting in the shadows. Predators like the cheetah are engineered to exploit weakened herds. They bring perfect camouflage, silent movement, and explosive power to the plains. But the animals they hunt are far from helpless. Millions of years of biological pressure have shaped these herds into highly specialized survival machines. Species like gazelles, pronghorns, wildebeests, and oryx operate as precise biological countermeasures. Every muscle fiber and behavioral instinct is calibrated to defeat specific, lethal threats. For these animals, fleeing is a calculated execution of evolutionary strategy. When a cheetah spots an isolated target, it relies on sheer explosive force, accelerating from 0 to 70 miles per hour in just 3 seconds. That top speed demands an immense biological toll. The cheetah can only maintain its sprint for 20 to 30 seconds before severe exhaustion sets in. The Thompson's gazelle counters that speed using geometry. While the cheetah requires a wide, sweeping turning radius to adjust course, the gazelle can execute a sharp 90-degree pivot without losing momentum. This forces the predator to rapidly alter its trajectory, draining its limited energy. The gazelle also utilizes vertical space. It springs 2 to 3 meters into the air in a behavior known as pronking. This sudden leap breaks the cheetah's visual lock and signals the danger to the rest of the herd. Upon seeing this signal, groups of 10 to 50 gazelles instantly scatter in different directions. This chaotic movement overloads the visual processing of a predator built to track a single target. By combining erratic angles and visual confusion, the gazelle successfully runs out the cheetah's narrow stamina clock. Across the globe in North America, the threat profile changes. The gray wolf hunts not through sudden sprints, but through relentless, long-distance endurance tracking. The pronghorn counters this tactic by maintaining an average speed of 40 miles per hour over distances up to 4 miles. The pronghorn's internal engine drives this stamina. It possesses lungs and a heart twice the size of similar mammals, processing oxygen efficiently at high speeds. It evolved these capabilities over millions of years to outrun the now extinct North American cheetah. Today, the pronghorn easily dominates the plains because its biology remains over-engineered to defeat a predator that no longer exists. Back in Africa, migration routes force entire species into severe environmental bottlenecks, like the fast-flowing currents of the Mara River. Submerged in these muddy waters are 1,500-pound Nile crocodiles, capable of launching precise ambush strikes from below. To cross safely, the wildebeest herd suppresses individual panic. They descend into the water at once, forming a massive, unified, and chaotic river of bodies. As they swim, mature adults instinctively form a physical barrier on the outer edges, absorbing the attacks to protect the highly vulnerable 50-pound calves positioned in the center. This crossing operates on a grim calculation. The herd accepts the inevitable loss of some members on the perimeter to guarantee the majority of the population reaches the new pastures. In the arid lands of Africa and the Middle East, the most lethal threat is the climate itself. Surface temperatures regularly exceed 120 degrees Fahrenheit, creating an inescapable heat. The oryx navigates this by extracting trace moisture directly from dry desert vegetation, allowing it to survive for days without access to standing water. Still, the primary risk in this heat is internal. When a large mammal moves during the day, its core temperature spikes, threatening the brain with fatal thermal damage. This schematic illustrates the oryx's internal cooling system. Warm blood is routed through a specialized capillary network in the nasal passage, dropping the temperature of the blood just before it enters the brain casing. This internal regulation acts as biological armor, ensuring the oryx remains alert, mobile, and capable of evading physical predators at the hottest time of the day. Scaling out, we see the massive physical footprint of these prey populations spread across the plains. Their constant movement acts as an ecological engine. By grazing on young grass and shrubs, they prevent vegetation overgrowth, while their passing fertilizes the soil to ensure new growth. The strict natural selection of the environment leaves behind casualties, providing essential food for scavengers like vultures and hyenas, which prevents disease from spreading across the plains. If these prey animals lacked their precise adaptations for speed and endurance, apex predators would rapidly hunt them to depletion, collapsing the entire food chain. This continuous tension between predator and prey establishes an exact balance. The daily struggle for survival secures the future of the entire ecosystem.